Trigonometry revision grade 11. Once again, here is a very cute examination question. This is one from one examination paper. They test a lot of things under trigonometry. So what do I need to know? Number 1 and 2, I must know very well how to work with diagrams. Diagram type questions. That's 1 and 2. Then number 3, I need to revise very well reduction formulas. So reductions, they go together with core functions. I must know how to apply the two. Then the next one, I must have a good understanding of identities. And then the last one falls under trig equations. So don't just know this one. Know trig equations very well. The next one is a general question, but it is also based on understanding identities. So that will give me about 41 or so marks if I'm able to do all these things. So let's go and answer these questions and see what is required here of us. And as you do answer them, make a note of what do you learn, or what is the question reminding you, because math is about learning ideas. Let's have a look at question 1 and 2. These are diagram type questions. So the first one is a diagram type question. The second one is a diagram type question. Let's look at what method is needed to answer this question. Number 1. Now, in question 1, the method is what you need. So all the time, express your equation in such a way that sine B becomes the subject. So express your equation in such a way that the trigonometric expression given there will become the subject. So in this equation, we can move the 2 to the right hand side where it will become positive 2. Then after that, divides both sides by negative 3. That will give you the value of sine B is equal to negative 2 divided by 3. Now, I'm going to draw my diagram in the Cartesian plane. So I need to know very well how to draw the diagram. Now, the next thing after this is to make some observations. You need to consider two conditions. The first condition is you look at this number, the value of sine B. After making sine B the subject, you will be able to see that, like in this case, we can see that the sine of B is negative. That is important for us. Sine B is negative. So then we now go to the quadrant and ask this question. In which quadrant is sine negative? And we know that sine is negative in quadrant 4 and in quadrant 3. It means our diagram must be drawn in one of those two quadrants. Condition number 2 that we must consider. We go to the range that is given. The question tells us that our angle is between 0 to 270. So there is 0 degrees here, 90 degrees up there, 180 there, and 270 degrees here. Now this covers quadrant 1, it covers quadrant 2, it covers quadrant it covers quadrant 3. Those are the 3 quadrants covered by 0 to 270. We need one quadrant that is between 0 and 270 and where sine is negative. So that points me to the third quadrant. Now I can draw my triangle in the third quadrant. The 90-degree angle is placed on the x-axis. So in this diagram, I put a 90-degree angle on my x-axis. The value that is given, which is the sine of B. So the sine of B that I have used to draw this is equal to minus 2 over 3. We know from our studies of trigonometry that the sine of an angle is equal to opposite divided by hypotenuse. So it means in this diagram, the opposite is going to be 2 minus 2, and the hypotenuse is equal to 3. Then immediately we calculate the third side using the theorem of Pythagoras. So let's say that the third side, which is not given here, is x. Then x will equal to the square root of 3 squared minus 2 squared. This will give me the square root of 9 minus 4. 9 minus 4 is equal to 5. So x is the positive or negative square root, positive or negative square root of 5. Because this is the negative side of the x-axis, it means I'm going to use the negative value, root and negative root 5. Now I have done the diagram. It is labeled. I can now answer whatever they ask me. In this particular one, we need the value of 1 plus tan squared b. Now, we simply now substitute. Go back to your diagram and read the value of tan b. Tan is opposite over adjacent. The opposite is negative 2. The adjacent is negative root 5. This is the tan and it is squared. So you put brackets here and you square. Then from there, you simplify this expression to get the answer. So this is 1 plus, if you square this, it should give us 4 over 5. Then 1 plus 4 over 5 is the same as 9 divided by 5. 9 over 5. So it looks like A, but this is 9 over 5. Then my question is answered. This is a diagram type question. The diagram must be drawn according to two given conditions. So in this case, we are to draw the diagram in a quadrant between 0 and 270, and in a quadrant in which sine theta is a negative number. Question number 2. This is also a diagram type question. But this one is very nice because we are given an acute angle. So the angle is the cos of 75 degrees is equal to m. We know that 75 degrees is found in the first quadrant. So there are no conditions to worry about here. We go to the first quadrant and put 75 degrees at the origin. So 75 degrees. Then the third angle is calculated using the idea of angles in a triangle add up to 180. So it's 75 degrees in one angle, 15 degrees another angle, then this one is 90. Just like what we did in the previous calculation, we know that the cos of an angle is equal to adjacent divided by hypotenuse. This is m over 1. So the adjacent is m, the hypotenuse is 1. You go to the triangle, the adjacent to 75 is m, the hypotenuse is 1. Then the third side is calculated using the theorem of Pythagoras. It will give us the square root of 1 minus m squared. Now I need to move on. Once the diagram is labeled and all information is in, I can answer the question they are asking. Let's go to number 2.1. We want to find the value of cos squared 105 degrees. The golden rule for trigonometry is that an angle must be an acute angle all the time. So before I can think of anything, I can see that this is 180 minus 75. I have to reduce it. Applying a reduction formula to this, it gives us the cos squared of 75 degrees. Then you go to the diagram and find cos 75. It's adjacent of hypotenuse, and the adjacent is m, the hypotenuse is 1. So cos 75 is m. Cos squared 75 is equal to m squared. That answers number 2.1. Number 2.2, I want the value of sine 15 degrees. I simply go back to my diagram. The sine of an angle is opposite of hypotenuse. So the opposite to 15 degrees is m, and the hypotenuse is 1. That answers number 2.2. Number 2.3, in the same way, I want to find the tan of 15 degrees. Tan is equal to opposite of adjacent. The opposite for 15 is m. The adjacent is the square root of 1 minus m squared. Then my question is answered. So this gives us the answers for question number 1. I need to know that some diagrams, they need to be done using specific conditions, and others you can do them according to the specific angle given. Then your question is answered. That's about it in this question number 1 and number 2. Right, question number 3.1. This one is based on reduction formulas and co-functions. Look for reduction formulas first. So reduction formulas, we take 108 degrees. If you see 180 and the multiples of 180, then the 180 falls away. So that means my first one, the 180 falls away. The resulting expression will become positive or negative according to the cast rule. The cos of 180 minus k is going to become negative cos k. Then I have 540 here. From 540, if a number is bigger than 360, you subtract 360 from it. So this is 540 minus 360 degrees. We notice that this will become 180. So this is the same as 108 degrees plus k. That's also reduction formulas. The 180 falls away, so I'm going to remain with the tan squared k, and this is in the third quadrant. Besides that, tan is squared, so it is a positive. Then I'm done with my reduction formulas. Co-functions, that's 90 degrees. The 90 degrees falls away, then sine changes into cos. So this one is the 90 degrees falls away, sine changes into cos. With this sine k minus 90, I must be careful because it changes the quadrant. So the cos is a negative cos k. That is my expression. Then negative angles. Negative angles are in the fourth quadrant. So in the fourth quadrant, cos is positive. Now this is just you knowing what to do the moment you look at your expression. So I can now write out the answer. It starts with negative cos k multiplied by negative cos k, then minus 1. At the bottom here, I have tan squared k, that's tan squared k multiplied by the cos of k multiplied by the cos of k. Then simplifying further, in my expression on top there, this is multiplication. It might be better also to put brackets when you're doing multiplication so that you don't make the mistake of subtraction. Cos times cos gives us cos squared. So I've got cos squared k minus 1. That is my expression in my numerator. Then in my denominator, I need to simplify that one. I have tan squared. what do we know about tan? We know that tan is the same as sine squared k divided by cos squared k. Then the two cos k times cos k there, they multiply each other to give us cos squared k. Now from this expression we can see that cos squared k and cos squared k are going to be divided out. What do we have left now? We are left with our numerator, which is cos squared k minus 1. Now remember, from our identities, sine squared x plus cos squared x is equal to 1. We can get 1 minus sine squared x, and we can get 1 minus cos squared x. I think I explained this in one question that we're doing. If we swap them cos squared k minus 1, then it means it is a negative identity. So this is a negative of sine squared k. Then at the bottom part, I'm dividing with sine squared k. Negative sine squared k divided by sine squared k. The answer to this question is negative 1. That is my answer for number 3.1. For 7 marks. So the 7 marks are not given to the quantity of the calculation. They are given to the application of formulas. Just to quickly explain what happened to that expression there. My identity is cos squared k plus sine squared k. Cos squared k plus sine squared k is equal to 1. So if we transpose the cos squared, we remain with sine squared k is equal to 1 minus cos squared k. So 1 minus cos squared k is equal to sine squared k. But if we swap these ones into cos squared k minus 1, then it means our identity on the left side is equal to a negative sine squared k. That's how we got the negative that is on top there. That is our identity 3.1 proved. Number 3.2. Determine the values of k from 0 to 360 for which the expression is undefined. If you hear this word, undefined, then it means you work with the denominator. An expression is undefined if the denominator is equal to 0. So to determine the values of k that can ensure that this is undefined, we equate the denominator to 0. So the denominator we may use here, instead of equating this complex denominator from our original expression, we can use the simplified part at this level here, where we have got tan squared k. So we can go ahead and say that tan squared k multiplied by cos squared k. This is my denominator. This must equal to 0. Now I am multiplying two factors both equal to 0. It means I equate each one of them to 0 separately. Tan squared k is equal to 0, or cos squared k is equal to 0. Then to find k, we take the square root of both sides, and here also the square root of both sides. So that will give us tan k. Tan k is equal to 0, and the next one gives us the cos of k is equal to 0. So 0, 1, and negative 1, those are part of special angles. So we should be able to know what the value of k, or if you have forgotten, you can use your calculator for this. The k is equal to 0 degrees. K is equal to 0 degrees. That is our first value. Then the next one k is equal to 90 degrees for both equations. So k is equal to 0 degrees. K is equal, for k alone, maybe if we were to separate them, k is equal to 0 degrees, then k is equal to 360 degrees. Then cos k is equal to 0. This will also give us a set of values there. K is equal to 90 degrees, or k is equal to 270 degrees. Now, if this question did not specify that they want values from 0 to 360, now we can express these answers as general solutions. This is another way in which a question can request for general solutions. So the first one, where k is equal to 0, would be k is equal to 0 plus h times 108 degrees. In place of h, you can use any variable, n or anything. Then the second solution would be k is equal to 90 plus h times 100 times 360 degrees. The one for cos will be 360, where h is an integer. That is our 3.1 and 3.2 solved. So the idea is that when working with a question that requests you to find values where an expression is undefined, equate the denominator of that expression to 0 and solve the resulting equation. That will give you the answers that are required for that question. Then 3.1, reduction formulas, core functions, then identities, and you simplify. Right, let's have a look at question 4, proving identities. Now, this is one simple question, but which may look complicated if you look from a distance. Now, let's have a look here. We want to prove this identity. Now, at grade 11 level, our identities are very straightforward. You need to know that cos squared theta plus sine squared theta equals to 1. That is the major one. Then another major one is sine theta divided by cos theta equals to tan theta. Those are the two identities that we do in grade 11. Cos squared theta plus sine squared theta is equal to 1, and sine over cos gives us tan. So when you are working out an identity, you must look for equivalent expressions that you can replace. Let's have a look at how to go about answering this one. We have fractions here. When given fractions, then apply the general idea of fractions. We know that when given fractions, addition of fractions, you make the denominators the same. To add fractions, you must multiply those fractions in such a way that the denominators of the fractions will become the same. Once the denominators are the same, you are now able to add the fractions. And that is what we're going to do in this question. So we're going to multiply the first fraction and the second fraction in such a way that the denominators will become the same. Now, because we are multiplying two numbers in brackets, we need the FOIL method. 1 times 1 times sine theta times 1, sine theta times sine theta. So the first one in expanded form gives us 1 plus 2 times sine theta plus sine squared theta. We have used the FOIL method to get that. Then the next fractions, we need to keep the negative because the negative must subtract everything after removing these brackets. Do the FOIL method here again to get your answer. It will be 1 minus 2 multiplied by sine theta plus sine squared theta. The denominator, we also are removing brackets. And if we want to be fast, we can observe that in our denominator, there is a difference of 2 squares. So a difference of 2 squares, you can multiply the first terms and the last terms only. That will give us 1 minus sine squared theta. Then we simplify going forward. Everything that happens after here, it's basic calculations that doesn't really give too much problems. So we have got 2 sine theta. I'm now simplifying, plus sine squared theta. Removing these brackets gives us minus 1 plus 2 times sine squared theta minus plus 2 sine theta minus sine squared theta. This is my expression. In my denominator, I am able to notice something there, but let me write it like that for now. This is 1 minus sine squared theta. Now, proving identity requires you to observe expressions that you can remove and replace with their equivalencies. 1 minus 1 in this case gives me 0. So if I simplify the numerator, we are adding 2 sine theta plus 2 sine theta. That gives us 4 sine theta. Then sine squared theta minus sine squared theta gives me 0. Now the denominator is equal to cos squared theta. If you remember your identities, you should know that cos squared theta plus sine squared theta is equal to 1. We can now get an equivalent expression for 1 minus sine squared theta. Now our identity is proved. We now have 4 times the sine of theta divided by cos squared theta. So to make this identity look like the right hand side of our identity that we are proving, we have tan there. Where does tan come from? Tan comes from the sine of theta divided by the cos of theta. So our expression is 4 sine theta over cos theta multiplied by cos theta. We split the cos squared theta into cos theta times cos theta. Then this one part here becomes tan. So the answer will equal to 4 times tan theta, then divided by the cos of theta. This is equal to the right hand side of the identity. I have proved my identity. The right hand side is equal to the left hand side. So just to remind each other quickly, when you see fractions and you are supposed to do addition, then remember to make the denominators the same. Then the identity that we're mainly focusing on is, there are 2 of them, cos squared x plus sine squared x. This is equal to 1. And I must keep in mind that we can write this, or we can express this identity in various ways. We can move the sine squared to that side, then it will give us 1 minus sine squared x. We must also know that in that form, we can factorize 1 minus sine squared x into 1 minus sine x and 1 plus sine x, using the idea of difference of 2 squares. This is my identity. We can express it in various ways. Be careful also with negatives when you simplify. So let's say, for example, I am given sine squared x minus 1. I know that my identity has 1 minus sine squared x, but if we swap it into sine squared x minus 1, then you need to know that your identity is a negative number. It is equal to negative cos squared x. Then another important identity is a tan. This one is no rituals, it's straightforward. Sine x divided by cos x. Then my identity is available. So you need to have them in mind, so that the moment you see something that you can remove, then you can remove it and replace it with an equivalent expression to complete your answer. This is the answer for number 4 and the ideas needed to answer the question. Right, let's have a look at question number 5. Determine the general solution of the given equation. Now this one is a very nice question, also very straightforward. I wouldn't expect a learner to get this wrong. Important is you need to know what to do when what happens. That is why it is important to do revision. It is important to study. Now, in this equation, if you see that an equation has got cos x and sine x, and one of them is squared, then it means you can use the identity cos squared x plus sine squared x is equal to 1. So you remove the squared identity, the squared expression, and replace it with an equivalent from that identity. Now, the thought or the idea behind this is that your trigonometric equation must have one trigonometric expression throughout. You must not have cos, sine, tan in the same equation. This equation has got sine and cos. So this substitution will make sure that the equation has got cos theta only. It is expressed in terms of cos theta. Once you do that substitution, the next thing is to simplify. 6 times 1 will equal to 6. Then 6 times cos squared x will give me 6 times cos squared theta plus cos theta. This is equal to 4. That is my equation. Now this, we need ideas from quadratic equation. Now it is squared. So a quadratic equation must always be in standard form. So that means you start by writing the squared one first. That's negative 6 cos squared theta plus cos theta. If we move the 4 to the left, it will become negative 4. So that's 6 minus 4. It gives us plus 2. This is equal to 0. Then to make the leading number a positive, we multiply the whole, we divide the whole equation with negative 1. Divide everything by negative 1. Then my equation becomes 6 times cos squared theta minus cos theta minus 2. This is equal to 0. From here, you have two options. One option is to factorize this equation. The other option is to apply to use the quadratic formula, or you can also complete the square. So you have to make a choice as to which one you can use to work out your answer. So this expression can be factorized. So I can express it in bracket form. This would be 3 cos theta minus 2 in one bracket, and in the other bracket it's going to be 2 cos theta plus 1. So this is equal to 0. After factorization, we now solve the equations, the two brackets separately. 3 times the cos of theta is minus 2 is equal to 0, or 2 times the cos of theta plus 1 is equal to 0. Then carrying on, move the 2 to that side and then divide by 3. It will give us cos theta is equal to 2 over 3. Then the next one gives us cos theta is equal to minus 1 over 2. That is my equations in a simplified form. Each equation here will give us its own solutions. So let's start with the cos of theta is equal to 2 over 3. You need to find the reference angle. So the reference angle, you use a calculator for that one. In our case here, the reference angle is equal to 48,19. Now, then you read your answers. So you check the number, the value of cos theta is positive. So we know that cos theta is positive in the first quadrant and in the fourth quadrant. So we look at this number here. That number is positive. So it means you must get your solutions from the quadrants where cos is positive. Cos is positive in quadrant 1, cos is positive in quadrant 4. And the measurement of the angles in those two quadrants, in quadrant 1 the angle is theta, in quadrant 4 the angle is 360 minus theta. These are my two solutions. In place of theta, you put the reference angle. So the first value is theta, which is equal to 48,19. Then the second value, theta is equal to 360 minus theta, which is going to be 360 minus 48,9. So simplifying this one, it will give us 311,81 degrees. This is the value of theta. Then to each solution, we add k times 360 to make it a general solution. So this is plus k times 360. Those are my two solutions. Then the next solution comes from the next equation, which is cos theta is equal to minus 1 over 2. Now notice in this case that cos theta is negative. So this number here tells us that theta is a negative number. We need the quadrants where cos is negative. Cos is negative in quadrant 2 and cos is negative in quadrant 3. So these are our solutions for that equation. Theta is the reference angle. So carrying on, I can say my reference angle I can find the reference angle using a calculator. Please, there is no need to put this negative sign in the calculator. We can use half as a positive number. So this is equal to 60 degrees. Then we use the negative sign to determine the quadrants in which we can get our solutions. So in quadrant 2, theta is equal to 180 minus theta, which is 180 minus 60. And simplifying this one will give us 120. To that solution, we add k times 360 to change it into a general solution. Then the next one will be theta is equal to 180 plus theta. So 180 plus theta will be 180 plus 60. That will give us 240. Then to 240, we add k times 360. We have solved the equation and we got our general solutions. This one is the first general solution, the second general solution, the third general solution, the fourth general solution. So there are 4 solutions in this equation. And the value of k, we must indicate the k that we have used as in a general solution, that k is an integer. That is our equation solved. You also have the option of when you get your equation in standard form before factorization, there I have 6 times the cos squared of theta minus cos theta minus 2 is equal to 0. You can use a different variable to just make your equation look nicer. So we can say let h be equal to cos theta. Then the equation can be expressed in terms of h. It will be 6h squared minus h minus 2 is equal to 0. Then in factorized form, that will be 3h minus 2 factor of 2h plus 1. It's not a requirement to do this, but if you want your your work to look a bit simpler, we can also do this. Then from here, we solve this quadratic equation. It's very easy now to see that it's a quadratic equation. The first bracket gives us 2 over 3, and the next bracket gives us, this is 1. The next bracket gives us minus 2 or minus 1 over 2. Then you can now say, therefore, the cos of theta is equal to 2/3. And for this one also, the cos of theta is equal to minus 1 over 2. You find the reference angles and you determine your solutions. So quickly to summarize, we start by noticing that our equation has got sine and cos. We need to express it in terms of one trigonometric expression. We remove the squared one and replace it with an equivalent expression that comes from the identity cos squared x plus sine squared x is equal to 1. Then we simplify our equation to standard form. After standard form, we apply the quadratic formula. We use factorization or completing the square. You use any method of your choice. Then when you are done solving it, you find the reference angles and read your answers from the quadrants depending on whether you have positive or negative numbers. That is my general solutions. There is one video we have explained a lot of general solutions and gave examples. You can refer to that one also for more information on how to solve this type of equations. We definitely need to know how to answer this kind of questions. Question number 6. Question 6 is on identities. So we need to remember our two major identities. P is equal to the tan of A plus the sine of A. Then Q is equal to the tan of A minus the sine of A. And what are we supposed to calculate? We need to find the value of PQ. So obviously, PQ from basic algebra means P times Q. This is going to give us the tan of A plus the sine of A. Then this is the value of P. The value of Q is the tan of A minus the sine of A. Then from there, we do the normal multiplication. Please make this observation. It will make your work a bit easier. Let's say I am multiplying A plus B factor of A minus B by using the FOIL method. I must be able to notice as a maths person that this is a difference of two squares. If you are multiplying exactly the same numbers that have different signs, then it's a difference of two squares. So in a difference of two squares, you multiply the first, you multiply the last. The answer to this question is A squared minus B squared. This will save time. This will make your work a bit easier. That's what I have in this expression. I have got tan A sine A, tan A sine A. So I can get my answer by multiplying the first one and multiplying the last one. Because the terms are exactly the same, it is a difference of two squared. Now, if I do that, it will give me PQ is equal to tan A multiplied by tan A. That will give me tan squared A. Then sine A times sine A, that will give me sine squared A. Now, I know something about tan. Tan is an identity. So if you see tan, we can replace tan with the sine squared A divided by cos squared A. Then this is minus sine squared A over 1. Now I'm back to fractions. Fractions have one rule. To add fractions, make the denominators the same. To add fractions, make the denominators the same. So in my expression, I'm going to multiply one fraction by cos squared A so that the denominators may be exactly the same. Then going forward, the sine of A, sine squared A minus, then the next one is sine squared A multiplied by cos squared A. This is all divided by one denominator now, which is cos squared A. Then from there, you need to remember that if an expression is addition or subtraction, you use factorization. If you look at that expression, there is a common factor, which is sine squared A. Then it gives me 1 minus cos squared A divided by cos squared A. Then we simplify it and work it out. Now, inside the brackets, we have an expression there that we can use identities for. We know that cos squared A plus sine squared A is equal to 1. So from that identity, we can replace that expression with the sine squared A, then divided by cos squared A. Then carrying on, still applying our identities, tan is the same as sine squared A, sine A over cos A. So this is sine squared A divided by cos squared A, then multiplied by sine squared A. I have put these two, one on top and the bottom one together, because that will form my tan. So this is equal to tan squared A multiplied by sine squared A. This is my value for PQ. I have proved the identity. PQ is equal to tan squared A multiplied by sine squared A. And that answers question number 6. In summary, this is the question that we have answered. Number 1, diagram type question. So you have to draw a diagram according to the specifications given. That's number 1. Number 2, diagram again, but this time around your diagram is in quadrant 1 because we are given an acute angle. Acute angles are in quadrant 1. Question number 3, reduction formulas and co-functions. I must know that I can take out this 180 and remain with cos k, but the remaining value must become positive or negative according to the cast rule. Something very cute here. If it happens by any chance that you have forgotten how to check the sign here, you can check the sign with a calculator. Get your calculator. In place of k, put any number of your choice, an acute number, let's say 1. Then you type on the calculator cos 180 minus 1. Then press the equal sign. If the answer is negative on your calculator, it means this must be negative. So there is no reason for this to get wrong because you can check with the calculator also. If a number is too big, more than 360, you minus 360 first, then apply reductions going forward. If you see 90 degrees, 90 degrees is a co-function. So the 90 degrees falls away, sine changes to cos, cos changes to sine. Then undefined. What do you do if they say find the values of x for which something is undefined? Equate the denominator to 0. Number 4, what do you do when you're working identities like this? These are fractions. Make the denominators the same and simplify your expression, then substitute with values from the identity. Number 5, how do you solve a general solutions equation like this one? You must make sure there is one trigonometric expression. Therefore, substitute the squared one using an equivalent expression from the identity, express in standard form, solve using the quadratic formula or factorization, find the reference angles, and determine the solutions. Number 6, what idea do we use here? We multiplied by the FOIL method and we're able to identify the difference of squares. Then that made our work a bit easier. That is this is about 41 marks. So it's a long question. It comes from one of the past grade 11 mathematics papers that we have. So go through the concepts and make sure that you have an understanding of them. Then it should work out for you when you write your mathematics paper 2.